Good afternoon. How are you doing? Very good. How many of you have been here all week? Yeah, very good, very good. Are you getting tired, or do you have room for more? Room for more? Okay, good, good. This is a talk I'm looking forward to, if you can believe it or not, because there's a lot of hype associated with this term, isn't there? Serverless. And we're very early stages, which means not a lot of people know what this means, which is a great opportunity for you, right? You come in early and you get to turn out whatever definition you want for what this means. Yeah? I won't be doing that to you, but what I will try to do is disambiguate this term a little bit, hopefully make a little more sense by the time we're all said and done. So as we said, my name is Scott Davis. I'm with ThoughtWorks now. And we have an opportunity to do a lot of these kinds of innovative technologies. We don't just talk about them and write about them and speak about them at conferences. We actually do this as well. If you have an opportunity, swing by the ThoughtWorks booth out here, and they have a build your own technology radar. The only reason I'm bringing this up is this is a technology that I think is very intriguing, but it's something you're going to have to evaluate. I'm not suggesting you want to adopt it first thing, but what I do want you to do is start thinking about it, start kicking the tires on it, start experimenting with it, because it holds a lot of promise. So, we need to define what serverless means, and we've only got 58 minutes to do it. So let's get started. I very rarely read text to you, but that's what I'm going to do to you right now. I'm going to read this to you. Serverless computing, also known as function as a service, or FaaS, keep that in mind, is a cloud computing code execution model in which the cloud provides fully managed starting and stopping of a functions container. Platform as a service is necessary to serve the request, and requests are billed by an abstract measure of the resources required to satisfy the request, rather than, I couldn't do it in one breath, rather than per virtual machine per hour. Any questions? Yeah? Wow, we still have 47 minutes. What are we going to do with all of our time now? Yeah? Believe it or not, this is a good definition. But the definition requires definition, which makes it a bad definition, doesn't it? But what we're going to do is talk for the next 56 minutes now, and we're going to continue to revisit this definition. And at the end of the hour, it might actually make sense. Yeah? So there's good stuff in that first paragraph, but let me focus on the second paragraph right now. Second paragraph says, despite the name, it doesn't actually involve code without servers. Okay, whew, that makes me feel better then, right? But why would they call it serverless? Have you heard some people say, it's not serverless, it's just someone else's servers? Yeah, that's a pretty good definition of what serverless is. Yeah, just someone else's servers, right? Because that's what the cloud is, right? Someone else's servers, someone else's services, someone else's operating systems, someone else's app servers, someone else's problem. Yeah? All you have to do is pay for the privilege. And while I'm being a little bit snarky about this is a very good definition as well. Because it does involve servers, but it does involve someone else's servers. And the point is here that I'm trying to solve a real business need. And that doesn't involve TC Server, or Apache, or Nginx, or Lydie, or Ruby, or JavaScript, or Java, or Scala, or they're business problems, right? And so often, our focus is on syntax and languages and frameworks and application servers and databases that we tend to lose sight that we're really here to solve problems. So that's my definition of serverless. Serverless is that you get to focus on business problems and business solutions instead of implementations. Does that make sense? All right. Well, we're making progress then. 55 minutes down and we've got a better understanding of what serverless is. But there were lots of as-a-services in that definition, right? We mentioned that serverless is kind of like function as a service, which is another form of platform as a service. Are you getting tired of all these as-a-services popping up? Yeah, I'm getting tired of it as well. But unfortunately, they're such good definitions that we have to stick with them. Software as a service, or SaaS, is different than the way we used to deal with software. I used to go to the store and buy floppy disks. I remember so vividly installing Windows 95 on my system. Do you remember how many floppy disks it took to install Windows 95? About 20. So 1, grind, grind. 2, grind. 3, right? And so floppy disks weren't the best way to transport software around. What did we evolve to from there? CDs, that was better. What did we evolve to from there? DVDs, that was better. We can start storing gigabytes of data. But what if we didn't distribute the software at all? We've got this wonderful thing called the internet. Have you heard of it? Yeah? And it means you can open up a browser, and any browser, doesn't matter which one, IE or Safari or Firefox or Chrome, and simply type in a URL, and guess what? You have software on your system. Maybe not on your system. Maybe it's shared a little bit on your system, some out in the cloud. Maybe it's free. Maybe you have to pay for it. But this is all we're talking about. Software as a service is really not physically installing anything, but still getting all of the benefits. And if you think about how pervasive this is right now, do any of you run your own mail server at home anymore? Do any of you run your own web server at home anymore? Your own database server? What happened? Did you stop doing software development? No, all of this is in the cloud now. Because what it's allowing me to do as a web developer is focus on building websites, not installing web servers, not patching operating systems, not managing databases. So software as a service, even though it seems trendy and it's easy to be a little bit cynical about it, is actually a great trend and something that really enables me to focus on business solutions, not boring implementation details. And SaaS is a big, big deal. It's hard to get a real estimate on what this is, but it's probably in the neighborhood of $20 to $30 billion a year. That's a lot. That's a lot. But once we understand software as a service as kind of a general term, then we start getting into all kinds of fun things like platform as a service and infrastructure as a service and mobile pizza ordering framework as a service and all kinds of specialized things from there. Yeah? But the easiest way to think about this as a service is really to kind of think about what it would be like to install software on your system using floppy disks. At the base is your infrastructure. You need to have hardware. You need to have hard drives. You need to have operating systems. But as you begin moving up, as you start getting into a platform, you start having web servers and database servers and things like that. And eventually, when you get to the top of the pyramid, you have software. So at the top of the pyramid is Gmail. At the platform level, that middle, are things like Apache Web Server and MySQL Database or MongoDB or something like that. And at the bottom are things like Linux and the NFS file system and good things like that. So it's really helpful kind of understanding how all these pieces move together. And while infrastructure as a service is a requirement, and software as a service is where most end users live, because that's what YouTube is, and Facebook, and Twitter, and Snapchat, and Instagram, yeah? but we're web developers. So we should be intensely interested in that middle tier, in that platform as a service. And it is a gradient. We could do some very low-level things like, oh, I just need a Linux distro and I'll install my own Apache instance. Or you could say, I need a Linux distro and you can install Apache for me. Or I could say, I'm a web developer and I'm going to assume that you have Linux and Apache already installed, but I don't know. I'm just going to kind of throw my web app at you. Can you see how we can buy in at any level? Yeah. So, platform as a service is really app servers, is really web servers and databases and things like that. And again, those are what should be especially interesting to us as web developers. And the reason I'm saying this is we're going to get back to this idea of what serverless is. But serverless is not infrastructure. And serverless is not your finished application. Serverless is where those servers typically live, which is that platform as a service layer. I love it when people start talking about private clouds, right? Because if you agree with the definition that cloud is just someone else's server, then what's a private cloud? Oh, rats, it's my server again, isn't it? Yeah, but that's okay. Sometimes you do want to run things on your infrastructure. The Portland, Oregon Transit Authority contacted me and they said, we want Google Maps without the Google Maps. I said, that's a neat trick. What do you mean by that? And they said, we love Google Maps, yeah, but we want to host our own data on our own server with our own mapping information. So they had made an evaluation there. They said we could live on Google Maps, and that's someone else's server and someone else's data. But what we want to do is move down that pyramid a little bit. We want to have that same Google Maps experience, but on our hardware, running our software. It was a fun project. If you go to ride.trimet.org, ride.trimet.org, it's still up and running, and it's been running for over a decade now. As a software developer, you love that, don't you? It's like, we won that battle. That software we wrote a long time ago is still running. But what was most exciting about that was we were able to go in there and establish that middle tier. We were able to go in and establish our own platform as a service. So, if you're talking about public clouds, which probably makes the most sense in this conversation, you've got some major players. We can see down at the bottom of this, they mention IBM Bluemix. We're going to discuss IBM Bluemix in here. We did discuss Amazon. You can't talk about the cloud without discussing AWS, right? Amazon Web Services. And you've got Heroku. And what's interesting about this is not all cloud providers are the same. In fact, Heroku sits on top of AWS. Have any of you worked with Heroku before? It's higher up the value chain, isn't it? You could go into AWS and provision your own EC2 instance, and then you could load it up with your own web server and your own database, and then you could manage routing and you could manage security. But Heroku says, we'll do all that stuff for you. And we'll provide a command line toolkit where you say, Heroku, push master into production. And that's all you have to do. You say, Heroku, push master, and you're in production. And it's automated all those things down the chain. So Heroku is more expensive than raw AWT services. And some people say, well, we can't afford that convenience, so they'll move down the chain and start managing that themselves. So Bluemix and Amazon and Heroku are all going to give us a better understanding of where we fall on that pyramid. Now, I said we can't talk about the cloud without discussing AWS because it is truly the 800-pound gorilla in the room when it comes to cloud providers. It's really interesting. Amazon started out selling books, didn't they? It's fairly not glamorous at all. It wasn't music, it wasn't delivering pizza, it was books and socks and underwear and really kind of boring commodities like that. But what's incredible about this is that about 10 years after they launched, they said, you know, we've had to build up all of these services to sell socks and underwear on the internet. And while it's made us a lot of money, we said, what would happen if we started renting you our infrastructure? We built the largest retailer on the planet, so we have a lot of knowledge. We know what it takes to run web servers at scale. We know what it takes to replicate databases. We know how to apply security patches in a timely manner. So what if instead of buying socks from us, you decided to buy a web server from us? Not something that we would ship to you on floppy disks, but something that you could rent from us. It would be in the cloud. You would have less money invested in hardware, in software, in system administrators, all these kinds of things. But we have excess capacity. Because, you know, that's the hardest thing about running these servers, isn't it? Is that traffic is bursty. On Black Friday, they need to have enough hardware to support all of that traffic. But then mid-February, when everyone is out of money and no one's buying anything, what are they going to do with all that excess hardware? Rent it. Let someone else who maybe sells greeting cards on February, Valentine's Day, right? Then their traffic is going to go up. But their traffic will go down as well. So then what happens in March? Oh, maybe Easter. And so then that traffic goes up and goes down. And so Amazon is able to amortize all of those bursty things by maintaining this much hardware. And then when they need that capacity, they have it. But when they don't, they rent it out. Software as a service, platform as a service, infrastructure as a service. And what's interesting about this is these aren't proprietary APIs that they're using. This is just plain old standards-based stuff. Everything they do is HTTP-based. Everything they do provides a simple REST interface. There are some SOAP interfaces in there, some XML, but for the most part, it's simple REST and JSON. So what they've managed to do is provide this very generic infrastructure that offers a high level of reuse. And it allows them to make money when they have a bunch of excess capacity. It allows them to make money when their demand is down. They started talking about this in 2003. They said, hey, what if we came up with a way that we could rent out this capacity? What if we had a way to kind of standardize access to our infrastructure? And if you can imagine, no other company had done that before. Taco Bell isn't saying, hey, you know what? We're not real busy after midnight, so if you wanted to come in and use our kitchen when we aren't using it, please feel free. Yeah? But that would be a great opportunity for them to make extra money. That's in fact what Amazon started doing. Their first service went live a couple years later, but by 2010, all of Amazon.com was running on this AWS infrastructure. So for almost 10 years, 7 years, they've been using the same APIs that you use. They've been using the same infrastructure you use. And if you think about this, there are a lot of companies out there who are critically reliant on having internet access that don't own any of their own hardware, don't own any of their own software. Google owns their own hardware. It's amazing. When they install hardware, they install it by the rack, right? And I don't know how many servers are in a rack, 20 or 30, right? They've done the calculations that they said when they install a rack, if one server goes down in that rack, it's not worth their time to deal with it. They wait till about 30% of the servers go down in that rack, and then they pull the whole rack and service it and jam it back in. So Google has decided it's in their advantage, it's their critical advantage that they're going to maintain that hardware. But a company like Netflix decided we're going to focus on business solutions, not infrastructure. Netflix runs entirely on the AWS infrastructure. They don't own a single server of their own. They don't have network administrators. Okay, they do, but they're administering someone else's servers, right? They're cloud administrators. Netflix represents 50% of all internet traffic in North America. YouTube represents another quarter of that. So it's incredible to think that 75% of internet traffic in North America is sending videos around. Yeah? And Netflix runs 100% on Amazon's infrastructure. And they're competitors. Amazon has its own streaming web service, video service, and Netflix does as well. And Amazon is actually renting out their servers to help their competitor do better, to help their competitor beat them in the market, right? And that sounds crazy. But when you realize that they're making money off of their competitor's business, then it's not so crazy anymore, right? AWS is profitable, and not just a little bit. AWS is the most profitable aspect of Amazon. It represents well over 50% of their revenue. And we're talking billions of dollars. Remember I said the SaaS market probably represents, 20 or 30 billion dollars of that? Amazon represents 40% of that. They are regularly making $2 to $3 to $4 billion a quarter just renting out their infrastructure. And they're really good at it. In that bottom paragraph, Gartner estimates that AWS customers are deploying 10 times more infrastructure than the combined adoption rate of the next 14 providers. Let me say this again, but show it to you in kind of a visual way. AWS represents about 40% of that market. The next three biggest competitors combined, Microsoft, Google, and IBM, represent half of that. The next three competitors combined represent about 20% of the market, which if you do the math on that, it means Google, Microsoft, and IBM all have single-digit market share when it comes to cloud providers, compared to 40% of Amazon. If we go to the next 10%, each one of them represent 1-2% of the market tops. So what we have is someone who is incredibly successful with this, and we have a lot of people who are trying to be incredibly successful with this, because there's a lot of money to be made in convenience. There's a lot of money to be made in letting someone else deal with all those boring, mundane issues. So what have we learned so far? We know that serverless is in fact not just no server, but someone else's server. It's a function as a service. And we're going to understand what function as a service means a little bit more in just a moment here. But we do have a better understanding now, hopefully, of what software as a service is, platform as a service, and infrastructure as a service. And I really want you to think of that pyramid whenever you think of any of the as a service kinds of things. Infrastructure is the bottom, and while that's critical, that's kind of commodity work. As you move your way up the pyramid, your value proposition goes up. You can charge more for that. And while at the tip of that, people expect a freemium model where we can use the service for free and opt in to the premium stuff, in the middle tier, in that platform as a service, there are very few free options. That is where most of that money is being made, and people are making it by charging for convenience. So, we're now 30 minutes into this, and we haven't talked about what serverless means. Should we talk about what serverless means? Yes, all right. Because I'm going to talk about what serverless means, and I'm going to give you a couple of real-world examples of what it is. But let's come back to this definition once again. Serverless computing, also known as function as a service, okay, that's feeling a little bit better now, yeah, is a cloud computing code execution model. That's a good definition of what serverless is. It's not an operating system in the cloud. It's not a database in the cloud or a web server in the cloud. It's an execution model in the cloud. We'll come back to that idea. But the cloud provider fully manages starting and stopping of that platform. So what we end up with is we aren't deploying wars. We aren't deploying entire applications. We're deploying an individual function. And we don't care about what server it's running on, and we don't care about maintaining uptime on that server, and we don't care about starting that server or stopping that server. We don't care about capacity planning or anything. What we have is a function that lives in the cloud, and it executes based on whatever trigger we set up to trigger it on. But the provider, the platform provider, is the one managing the function itself and making sure it's up when that needs to be triggered and it goes away when it's no longer in use. You're deferring all of that non-business value adding junk to someone else. And you're focusing purely on the function, purely on the business value. Does that make sense? Yeah. Well, let's evaluate this a little bit more, and then we'll give you a couple of good examples of what we're talking about. So you're probably familiar with EC2. EC2 is your PC in the cloud. It's your server in your cloud. It's like a physical thing. It's got an operating system. And you know, you can have EC2s running Windows or Linux or any operating system you want. That's great. When you configure that EC2 instance, you say, I want it to have this much RAM, I want to have this much CPU power, I want it to have this much hard drive space, right? You set it up, and then you set it up to run. You set it up to run constantly, 24/7, or maybe you need it just for a little bit of time, and when you're done, you manually shut it down. There are a lot of media organizations. The New York Times famously did this. They wanted to go in and digitize their entire back catalog. And this back catalog goes back hundreds of years, yeah? And so they wanted to digitize all that, and so they bid out. They had their IT staff figure out how much money it would take to build all the hardware they need, all the scanning hardware. Obviously, this was going to be very intensive, right? Because they want high-resolution scans, and that takes a lot of space. And they need to be able to process that. They need to be able to move it around and group it and all these kinds of things. And so they bid out how much it would take in terms of hardware, in terms of administrative costs and data centers and all that. And after they had done all that estimation, they said, oh yeah, we forgot to mention, we're just going to need that for a weekend. And they said, you had us build out millions of dollars of infrastructure for 96 hours of work? They said, yeah. Are you okay with that? I said, what are we going to do with all those computers when we're done? They said, have you heard of what Amazon's doing? Because that could be a really good model for us. But in fact, they didn't set up their own infrastructure. They ended up using this on Amazon. And they did exactly that. They brought up that infrastructure for what ended up being 3 or 4 days over a weekend. They processed everything that they needed. And it was not only a dramatic cost savings, but after the work was done, it didn't continue to incur costs. It just went away. Now that example happened years ago, and that example, they turned on the server, they utilized it, and then when they were done, they turned it off, and that's when billing stopped. That's the EC2 story. The Beanstalk story is more like the Heroku story. It's farther up on the hierarchy. You don't have to install your own operating system. You're not quite worried about that. You get to decide, oh, maybe I want a web server in this kind of database, but Beanstalk is far more abstract. It's farther up that chain. And Lambda is even farther up. If we look at this definition of Amazon Lambda now, it runs code in response to AWS internal or external events. So when we're talking about functions in the cloud, functions as a service, we're interested in what's going to trigger that function to be called. This is what we're going to talk about in just a moment here. But something is going to trigger that function to be run. And when it gets triggered, like an HTTP request, like a cron job, like some other event, Lambda will spin up, run that function, and then go back down again. So in terms of the real-world examples we're going to talk about here, AWS Lambda is the one we're going to talk about first. Notice that Google has something called Cloud Functions. We could talk about that, but that's very similar. So I don't have anything against that at all. It's worth looking into, but it's not different enough to be interesting. So after we get done talking about AWS Lambdas, we're going to talk about OpenWhisk. And OpenWhisk is a way that you have a private serverless experience, which again is completely counterintuitive, right? The whole point of the cloud is that someone else's servers, but you now through OpenWhisk can incur all of that hardware and administrative costs yourself using an open source framework, yeah? And the last thing we'll talk about is serverless, which is more like a Heroku or a Beanstalk in that it runs on top of Amazon Lambda, but it is a far more refined user experience. It takes even more decision-making away from you, and I mean that in the best possible sense. So in the 30 minutes we have left, we have 3 more things to talk about. We're going to give you some good examples of how you might be using serverless, and then we'll give you 3 concrete implementations. Does that sound like a good use of our time? All right, halfway done. So what is serverless? And I really like this definition. Serverless is a new cloud computing trend that changes the way you think about writing and maintaining applications. If you were at the town hall last night, you know that syntax doesn't interest me anymore. Those are boring implementation details. We want to focus on ideas and concepts. And so serverless isn't an implementation. It could be Lambda, it could be OpenWhisk, it could be Bluemix, it could be any number of things. But that's not the interesting part, and that's not the challenging part. The challenging part is changing the way you think about doing software development. I said this earlier, we will say it again, we want to focus on code, not servers. And that is so difficult for us to do because if I say, what kind of programmer are you? And you say, well, I'm a Java programmer. It's like, okay, that's not important. And you say, wait a second. That's all of what I do, right? He said, no, that's not important. I don't care. We're just going to write a function, but I don't care what syntax you're going to use. All right, what web server should we use when we go into production? Do you want to use Tomcat? Do you want to use Wildfly? Do you want to use a WebSphere? And you'll choose one of those, and I'll say, okay, that's not important either. And you say, hold on. You know, don't I need to worry about jars and wars and ears and configuration files and all that? No, that's not important either. I want you to focus on business value. I want you to focus on what you're trying to do and not get bogged down with syntax and servers and things like that. How are we going to store that data? Oracle? NoSQL? Mongo? Couch? Yeah, it doesn't matter. Really? Really, it doesn't matter. All right. So this function as a unit of application logic is what we're going to focus on. What we're trying to do is narrow our stuff down to a single function. And for years, you've heard me and others talk about how important it is for your functions to be highly cohesive and loosely coupled. Highly cohesive and loosely coupled is what we're looking for. Highly cohesive means your function does one thing very, very well and nothing else. Yeah? It manages customers or it manages a shopping cart, but it doesn't manage customers and a shopping cart and your inventory system and your sales tax. Yeah? That's a monolith. So we like this idea of microservices Not because that's the hot new word, but because microservices are just another way of saying this is highly cohesive. Yeah? It's a function as a unit of application logic. It's the narrowest thing that we can deploy. Now, we also want our microservices to be loosely coupled. And what we mean by that is, well, in order to deploy microservice A, we need to have B and C, and we need to deploy them in that order as well, right? Otherwise, we're in trouble. Yeah, no, that's not what we want. We don't want that coupling. We want them to be independent of each other. And so sometimes people say, well, we've got these microservices, and it's great, but they've got this shared bus behind the scenes. And I know they're not really supposed to talk to each other, but we got a lot of bus traffic going back and forth. So yeah, that's coupling too, isn't it? Yeah. So when we're talking about microservices, and what I love about this slide is it doesn't mention microservices once by name, but a rose by any other name is just as sweet. And this is what they're discussing right here. It encourages a development focus on well-defined units of business logic without the premature optimization that starts thinking about, well, how is this going to behave under load? It's too early in the process to start thinking about that. Well, clearly we're going to need to cache it, otherwise it'll never perform. Not our concern right now. Well, we're going to cache it client side, and then we're going to cache it also. Not our concern right now. Those are concerns. But because of where we are in the process, Lambda or OpenWhisk is the one that should be worried about capacity planning. It should be the one that's worried about spinning that up in a timely manner, executing it, and shutting it back down again. We get to focus strictly on business logic. And this granularity of application logic also comes into the billing model as well. And you might say, well, that has nothing to do with business focus, and I agree with you. But we can't have a business discussion with talking about what it's going to cost. A typical Amazon web server, a typical web server in general when you're up in the cloud, typically costs between $30 and $40 US to run a month. If it's up and running 24/7. Of course, there's a huge variation in that, but just to give us a round number to kind of begin talking about. That web server up and running 24/7, 30 days out of the month, probably costs us about $30. Yeah? How often is that web server getting traffic, though? We could look at it as every time it's not getting a request, it's costing us money, and every time it's satisfying a request, it's making us money, right? And so capacity planning is all about optimizing that. We want to have just enough capacity to satisfy all of our requirements, but not too much. Yeah? Well, the billing model of function as a service, of serverless, fits that mentality perfectly. Because you are not paying for this when it's not being used. You're not being charged for this when it's not being invoked. So the way the billing model works is just as granular as your microservices are. You have that up and running, and it's just hanging out in cold storage. And when someone needs it, the clock starts ticking, and then when it's done, the clock stops ticking. How many of you own your own car? Yeah, very good. Do you rent it out at night when you're not using it, when you're sleeping? Why not? You're missing a huge revenue opportunity, right? When I travel, and I travel a lot, I used to rent a car almost everywhere I went. Because I said, you know what? It doesn't matter that I'm getting charged an exorbitant amount of money for this, right? I'm getting charged $30 or $40 a day. I don't think to myself, well, I better drive a lot when I have a rental car to make sure I'm getting the most out of my money, right? What I've discovered now is I can take a taxi or a Lyft or an Uber or a bus or a subway. I can do something where I am just being charged for the duration of my trip, and then the cost goes down. And what's amazing is getting around in a city now costs me $10, right? Maybe $5 in the morning to get where I'm going and $5 to get back. They're little micro payments, but what I'm paying for is the trip, not the capacity. Yeah? All right. So there are all kinds of use cases for Lambda. Because again, serverless is about changing the way you think about things. It's no longer about high availability. We don't want to have something up and running 24/7 and not being utilized. We want to start thinking of this in terms of an event-driven mentality. We want to start thinking of this as like, oh, you know what? Every time someone uploads an image, we want to turn around and create a thumbnail and publish that. Wonderful. That's an event, isn't it? That could be a serverless function right there. So the trigger is when someone uploads an image. The function, the microservice, would say, I'm going to take that image, I'm going to create a 500 by 500 pixel thumbnail, and I'm going to publish out to an S3 bucket. There, I'm done. Rather than having a web server that's up and running 24/7, listening on an HTTP GET that will do that behavior, in fact, what it'll do is the upload will trigger that. The function will wake up, do what it needs to do, and go away. And there are a lot of things that fit this model nicely. Uploading a video to YouTube could be the same thing because you need to transcode that for Android devices and iOS devices and home consumption and everything else. You can think of it in terms of HTTP requests, but really it could be any number of things. It could be a cron job. It could be IoT sensor readings. Maybe I have sensors in my house where if the temperature exceeds a certain threshold, I want it to send me an SMS text message. And rather than paying for a server to be running 24/7, 365 days a year, when that may never occur, my furnace might not fail in a given calendar year, but I still want to have that warning service available to me. If my furnace doesn't fail in that year, I pay 0 for my Lambda. But if my furnace does fail and the sensor does exceed that threshold and the Lambda does wake up and it does send out that SMS, I am paying for the unit of execution, not the capacity. Yeah? So there are lots of fun examples we can think about when we're doing this kind of thing. So let's give a couple of concrete examples of how this might be used. Amazon kind of pioneered this concept, and so we would be remiss if we didn't discuss them first. If you're trying to do something like this into production, I'm almost certain you're going to be doing it as a Lambda, unless you are an already existing Azure customer or Google customer or something like that. With 40% of the market and the tooling around this, this is kind of the 800-pound gorilla in the function as a service or in the serverless space. So AWS Lambda is an event-driven serverless computing platform provided by Amazon as a part of Amazon Web Services. Wow, these definitions are beginning to make sense, aren't they? It's incredible. It's a complete service that runs code in response to events and automatically manages the computing resources required by that code. Finally, clarity, this is beginning to make sense. And they go on to discuss the purpose of Lambda as it compared to EC2. So it's helpful having these mental models in place. Oh, if I do need something up 24/7, I've got this. Oh, if I want something to run on demand, I've got that. But notice these Lambda instances will respond to within milliseconds of an event. Within milliseconds of an event. And so there will be a little bit of latency with this. Are you worried about latency when it comes to creating thumbnails or transcoding videos or cron jobs that run every night at midnight? Probably not. They aren't very latency aware or latency concerned. But if you do have things that need to be incredibly responsive, this might not be the solution that you're looking for. So it's helpful understanding where it will be good and where it won't be good. Currently, you can implement your functions in Node.js, which of course means JavaScript, right? Or Python. Recently, Amazon has added both Java and C# support as well. You want to be aware that those are heavier weight languages, And so they might not be as performant as some of these lighter weight languages, because these lightweight languages, we want them to spin up instantly, execute and go away in a hurry. And there's overhead to the JVM. The JVM is meant to be this long-running service. That's how Hotspot does its optimizations. Over time, it does code optimizations. And we don't have time with Lambda functions. And so while you shouldn't choose the language based on the business problem you're trying to solve, you might want to consider the language you use to solve this particular business problem just based on the performance characteristics. This is an easily solved problem, though. And if Amazon finds that 80% of their customers are writing Lambdas in Java, you know what they're going to do? They're going to optimize the hell out of that, aren't they? They're going to make sure your Java Lambdas run just as quickly as everything else. But typically, Amazon is focusing on JavaScript solutions and Python solutions first. They're very fast languages in this context, and so betting against Node.js in an AWS evaluation is probably not a wise one. I like this graphic because it helps us kind of visualize time frames as well. A data center we could deploy in months if it's already been built. If we have to break ground, it could be years, right? But a data center takes months to deploy and lives for years. When we talk about virtualization in the cloud, we can deploy in minutes and hopefully it'll run for weeks, you know, the idea that we'll be upgrading it frequently. Container deployments, we can deploy in seconds and we hope they'll live for minutes or hours. But Lambda, we deploy in milliseconds and it lives for seconds. They're these tiny ephemeral little things. Light as a feather. So if we want to get started with AWS, this is going to be a goofy little hello world example, but we'll move on very quickly to a more real example. But if you want to create a Lambda, you'll log into the service. Of course, you'll need to have an account for this. The nice thing is Amazon is really promoting Lambda right now. So you can do a lot of evaluation for free. And unlike EC2, where you have a server up and running and you're concerned about shutting that down because the meter is running, you should feel very comfortable about doing Lambda development to experience it, because you won't incur any costs until you execute your Lambda. And your usage thresholds will probably be so low on that to begin with that Amazon probably won't even charge you for it. You'll have to look at those usage thresholds, but I'm telling you this is a very, very inexpensive solution, especially when you're trying to evaluate it. Yeah? So when you log into that console, the first thing you're going to say is, hey, do you want to create it from scratch, or do you want to utilize one of these blueprints? I always like pointing people to the Hello World blueprint, because that's about as simple as it's going to get. So if you choose a Hello World blueprint, it'll be saying, all right, give this function a name, give it a description, choose the runtime, that could be Node or Python or Java or C#, and then right there, in the form itself, in the web form, they're like, okay, go ahead and type your function. Like, really? Is that all there is to it? Like, yeah. You don't have a server to worry about, right? That's someone else's problems. You don't have a manifest file you need to worry about. You don't need to worry about dependencies or anything like that. You just write your code in line and deploy it. Now, that's great for kicking the tires. It's probably not a long-term strategy. And so you can see you can zip up your code, or you can zip it up and serve it up from an S3 bucket. And that's where it gets especially interesting, doesn't it? You could deploy to an S3 bucket, and then you could have a Lambda that's listening to that deployment that refreshes your website accordingly. So once you get into this event-driven mindset, it opens up a whole new set of possibilities. But doing it in the web page itself is probably not what you're going to do long term. So there are a number of gulp and grunt tasks that, as you can imagine, are well written and fairly straightforward. All they do is take your code, bundle it up, push it to Lambda. Yeah? So here's the real world example. I've been spending a lot of my time here this week in India talking about conversational UIs. Amazon Alexa is one of my personal favorites these days. And I love it because it's an open platform. It's based on standards, which is really cool. So if you go through and you want to write your own skill for Alexa, asking her to do something new based on this conversational UI, there's a great GitHub repo out there that you can pull down this code. This is Amazon's repo. But what you do is you go through and say, all right, let's go in and create a new skill. Let's go into that same screen, define your skill, name it, define all of your intents and what it's going to do. But how do you implement your skill? They recommend using a Lambda. So they give you this code that you need. You can zip it up. You can apply it to Lambda. And then every time you say something to your Amazon Alexa, it will spin up that Lambda, service the request, and shut it back down again. So if my new skill was, hey Alexa, tell me the weather in Bangalore, right? That service would come up and run just long enough to display the weather in Bangalore and go back down again. So this is a great practical example of how you would use these Lambdas. We have an action displaying the weather in Bangalore. We have a trigger, in our case, a vocal request, and the Lambda spins up, executes it, and goes about its business. We think in terms of URLs quite a bit, but we also should start thinking in terms of ARNs, Amazon Resource Names. And so we can see in here that when you add your new skill, My Fact, you need to come in here and associate it with an Amazon resource name, a serverless that will end up with your response. You can also point to a regular old HTTPS server as well, and that could be your server or something running on an EC2 instance. But as you can imagine, that's really not quite as an appealing solution because you'd be paying for that service to be up and running when no one is using it. It doesn't make sense for Amazon to keep it up and running when no one's using it. It doesn't make sense for you to keep it up and running when no one's using it. Lambda is the perfect excuse to take Lambda out for a ride. And in this GUI that they have here, what I love the most is they've got debug sessions right there so that you can see, you can visualize what the Lambda request looks like, the JSON payload coming up, and you can see the JSON response that comes back. So one nice, easy way to get started with AWS Lambda is to get started with conversational UIs. Now, another good solution out there is OpenWhisk. And I like OpenWhisk because I like open source solutions. I like standards-based solutions, and I like open source solutions. So OpenWhisk is a serverless open source cloud platform that executes functions in response to events at any scale. Wow, we start throwing enough definitions here, and these definitions start making sense, don't they? Isn't that nice? So, Whisk, fine-grained resource consumption. Yeah, we've heard that before. Yeah. Build by the millisecond. Yeah, we've heard that before. Use any language. So when I say it doesn't matter if you use Java or JavaScript or Swift or C#, I mean it does to you as a developer at some point, but that function, it doesn't really matter. And so it's another opportunity for polyglot. I could write some of my microservices or some of my Lambdas in JavaScript, some in Java, some in Ruby, some in Swift. It doesn't really matter. So what's interesting about OpenWhisk is that IBM has sponsored it. So what we will find is that people are concerned about cloud vendor lock-in these days. And that always makes me laugh because they're like, I'm really concerned about going with the industry leader with 40% market share. I would greatly prefer to use this other vendor. They're third on the list, but they've got 1% of the market. Yeah, so vendor lock-in is not typically a concern of mine. It is, of course, you know. But OpenWhisk, as much as it promises to be vendor neutral, it's pretty darn tightly coupled to IBM Bluemix right now. So if you're evaluating Bluemix as one of your things, OpenWhisk should be very appealing to you. It's much like the Cloud Foundry tool. Cloud Foundry tool can be used to manage everything, but you know that it does better with some cloud providers than others. And OpenWhisk, I would imagine the same thing. But here's what I do like about OpenWhisk. OpenWhisk, because it's open source, it will allow you to run that cloud on your hardware as well. Lambda doesn't have an option for you running that on your iron. You must run that on Amazon's hardware. That's the value proposition for them. We got all this hardware, we're trying to utilize it. OpenWhisk would allow you to run this on your hardware. And while I probably wouldn't be incentivized to do that in production, I would love being able to run this on my developer box. I would love being able to run this in a QA environment, a test environment, and then put it into production on IBM's hardware. That's a really compelling reason for me to look at something like OpenWhisk. So OpenWhisk has many of the same concepts. They call them actions and triggers. So triggers will be associated with specific events like, oh, adding a new row in a table, doing a commit in a GitHub. Sensors, once again, people love talking about this in the IoT context. But once we have a trigger, we have an action that's going to turn around and do something. Oh, if that IoT sensor hit a certain threshold, the action will be send me a text message saying it's getting hot at your house. OpenWhisk has a lovely command line toolkit. So once you install that Whisk toolkit, this is all it takes to create a new action. Whisk action, create hello.js. And that creates two big files. Not even big files, two tiny files. One is a stubbed out JavaScript file, and one is a YAML deployment description. And that's it. That's it. So it's really nice having something that will boilerplate that for you. Now, what you'll need to do is go in and start creating your own action. So your action is just like it would be in Node.js. You can npm install whatever you need. OpenWhisk will manage all the requirements. In fact, what you will do is zip up all those requirements and deploy it. So you're in charge of those kinds of things. But in this case, once again, let's say we get a location like Hyderabad. We get a URL like these Yahoo APIs. We can build up a URL, we can make that request, we can get the JSON response and hand it back. That would be something that would be up and running for maybe a second or two and go back away again. Once it goes back away, you want to turn around and deploy it. And so you'd use this Whisk to set your API host. Again, it'll probably be either Bluemix or something you're running in-house, but you're going to authorize it. You can use it to list out whatever actions you have deployed. And this is what's really nice. You can invoke these actions. I'm always interested in how easy this stuff is to test, to mock, to model, and being able to do this Whisk action invoke the weather. So I don't have to wait for the temperature to get above 100 degrees Fahrenheit. Yeah, I can trigger this on my own. So OpenWhisk. A really nice, compelling story. It's available on GitHub. You can pull it down, kick the tires. It will require you to have a Bluemix account set up, even if you're not going to deploy it to Bluemix. So that's the one interesting caveat as we go along there. But it is open source, and it's a nice little framework. But speaking of frameworks, we got serverless. Now, serverless is interesting because it is tightly coupled to Amazon Lambda. They don't make any bones about it. What this is this is the Heroku of serverless. This is something that adds value to the process on top. I really liked OpenWhisk because it would allow me to script up a bunch of things from the command line. Serverless, you script up from the command line as well. So this is all you need to know about serverless. npm install serverless. Once you have it, say serverless create, and based on a template. In this case, the template we're using is AWS Node.js. There are a number of other templates supported. Once you have that template in place, it puts a whopping 2 files on your file system. You implement that file however you need to, and then you say serverless deploy. That's literally it. So this is the sugar that serverless is. It's just streamlining your path to AWS Lambda. So if we go in and look at that real quick, here's another walkthrough. You'll npm install serverless. You also can have actual templates, not just raw files, but if you say, oh, this is a template that we use over and over again, you can create your own corporate template and then use that as the boilerplate instead of raw text. But once you turn around and do that, boom, you turn around to deployment like you would otherwise, and you go about your business. So there is nothing to the serverless framework, and there's everything to the serverless framework. It really relies on Amazon Lambda. It's not going to get you to OpenWhisk or anything else, but what it is a number of incredibly convenient methods that allow you to boilerplate and template and get to production in a hurry. So, we've covered a lot of ground here. But really, I told you we were going to come back to this definition. I'm going to read it to you one more time. Hopefully no one will laugh at me this time. Very sensitive about that, yeah? Let me read this one more time and see if it makes sense. Service computing, also known as function as a service, is a cloud computing code execution model in which the cloud provider fully manages starting and stopping the functions container platform as a service as necessary to serve requests. And those requests are billed by an abstract measure of the resources required to satisfy the request, rather than billing it out by the hour. My goodness, did that make sense this time? Holy cow, we might have accomplished something then, right? You can use Amazon Lambda if you would like. You can use OpenWhisk if you would like. You can use serverless to get you onto Amazon Lambda in minutes. But the idea here is that serverless requires you to change the way you think about doing application development. But once you do, it'll be incredibly practical, and I think you'll use it quite a bit. Did you enjoy yourself? I did as well. Thank you so much.